So today we're looking at section 1.3, and this is the continued version, and it's looking at the distance formula. So last time we looked at the midpoint, and now we're looking at the distance formula within 1.3. So when we look at the distance formula, what we're really looking at is a form of Pythagoras' theorem. And I know we haven't talked about Pythagoras' theorem, and it'll be in a later chapter, I think like chapter 7 or something. But we do need to look at that, and then it'll make more sense where we get the distance formula from. So I do have this misspelled. Really, you'll notice it. The distance formula is really just a fancy form of Pythagoras' theorem, like I said. And then in order to do this, let's go ahead and we'll make a triangle. Hopefully yours looks a little bit better than mine. But we'll make a nice little triangle here. And then we're going to label the different parts of it. First of all, we are dealing with a right triangle, so we'll draw the little box here, which signifies a 90-degree angle. Now, if we were looking at Pythagoras' theorem, we would label each side. So we're going to label each segment as a line. So remember, what type of letter do we use to measure a line or to write a line? Hopefully you're saying a lowercase symbol. So we'll write in each of these. So this is really looking at part of Pythagoras' theorem. So let's go ahead and make a graph. So in this case, I'm just going to make a graph in quadrant 1. And we'll write some stuff off to the side. You could just put this all on your other piece of paper. It might be easier for you to do that. But we're going to make a graph, and now we're going to put our triangle, like what we drew over there. We're going to put that triangle in our graph. So let's go ahead and make our triangle. And it should be about the same size, but I'm not concerned about the size. It is a right triangle. And then what we're going to do is we're going to label each of the points. So let's arbitrarily label my points here. So let's look at this point, and we're going to go ahead and label this A. And for point A lies somewhere in the X direction. Okay, so I'm not sure where this point is, but this is going to be my X value. So I'm going to let this be X1, we'll say. So this point A is X1, comma, maybe I should change colors so you can see my comma. So X1, comma, my Y value. Well, this is going to be a point on the Y-axis, so we're going to say this is Y1. So this is X1, comma, Y1. Okay, yours should be a lot smaller and a lot neater, hopefully. We're going to make a point over here, doing the same thing. This one, just because I have it in my notes labeled as C, we're going to label it C. And this point C, again, lies somewhere in the X direction, so this is going to be my X2 value. So C equals X2, comma, and then my Y value. Well, I already have my Y value labeled, so my Y value is still the same as this one over here. So this is X2, comma, Y1. Okay. Have that point located. Now let's go and label our last point, which would be our B, because of how I have it set up. B then is, keep forgetting to change colors. B then, well, I already have my X2 labeled, so B is X2, comma, and then I need a new Y value, so we'll go ahead and put a Y value up here, and this will be Y2. Okay, so now I have all of my points labeled, kind of arbitrarily. We could put actual numbers in, but then we wouldn't be able to justify it for everything. So before I start to apply Pythagoras' theorem, there's one other thing that we need to look at. I'm going to move my stuff so I can see it a little bit better. but we need to find the distance between these points. So if I was going to find the distance, and this is why hopefully you have a little more room than me, my distance that I have here is this right here. And how do we find the distance between 2 points? Well, distance x2, so actually the absolute value of x2 minus x1 absolute value. So the absolute value of x2 minus x1, that would be that distance. Well, if we're looking at the distance here, we know that the distance between these points then is the absolute value of y2 minus y1. Okay, now we have one more line that we want to find the distance for. Can we say this is x2 minus x1 or y2 minus y1? No, because we have a diagonal line. So we have to do some other things. If this was a nice straight line, then yes, we could do that, which is what we've been building on. We looked at points the first day, we looked at finding the distance of a line the second day, and then segment addition. Now we're moving to the point where we're taking things and applying the next concept. So we're going to take this, and we'll take this object, I'm going to move it over so that way I can still see it, and write stuff down as we do this. So Pythagoras' theorem states this. If I have, well, we'll just do this. Pythagoras' theorem says we have a squared equals b squared plus c squared. See if I can make this look a little nicer. Okay, now I want to try to use this in order to find out what Pythagoras' theorem is. In my hypotenuse, which is the length that I have over here in blue, and I'll put it in yellow over here so we can see it a little bit greater. This length right here, that's our a squared value, that's our hypotenuse. So we're going to say that a squared is going to equal our other two distances, the b and the c values. So a squared, which is just representing line AB, because we're looking at that line, and we're going to say this value is squared. So it's replacing that line value, the yellow line, is replacing our a squared. Equals b squared. Well, b squared is one of our sides. It's one of our x values. So I'm going to go ahead and let it be the bottom one, but it could be the top one. And b squared is going to be my x2 minus my x1 squared. Now, earlier we said the distance was the absolute value of this. Well, whenever you square something, your answer has to be positive. So we don't need to write the absolute value sign in. So then we'll take this plus, so this right here is my b squared. And then I'm going to take the y, and that'll be my c squared. So I'm going to say this is y2 minus y1 squared. And again, don't need the absolute value, because I'm squaring the number and therefore it'll be positive. So if we look at this, now we have something that looks like our distance formula, and it's part of the Pythagoras theorem. The only thing left is to solve for AB, and if we wanted to write this, we'd want to square root it. So we would square root both sides in order to undo the squares. And specifically, it just undoes this first one. So the square root of a square is the value. So AB equals the square root. And because we haven't done anything, we don't want to undo anything. So x2 minus x1 squared plus y2 minus y1 squared. Okay, there's my distance formula.